Hi everyone. I'm Robin, DevRel at Avail. Today I'm going to be talking to you about how to build a rollup with Avail. But before that, I'm just going to go quickly to let you know about what Avail exactly is, so that we get some context about what we're actually doing here. Um, Essentially, right, what are the challenges we facing today in the rollup space? Um, there's multiple rollups out there. Rollups are essentially trying to scale execution, but at a point after execution, DA or data availability becomes the major bottleneck for Web3 rollups and L2s, and because you need block space, which is quite expensive on Ethereum, even with blobs right now, post EIP 4844, we need excess block space in order to cater to this rollup centric roadmap that Ethereum has. So rollups need DA to scale. There's a UX fragmentation with the number of rollups that's popping out every day, and we need a framework for unifying all of these different rollups, right? So like I said, Ethereum rollups have taken the center stage. Like, how many rollups are you using every single day on a monthly basis, or maybe on a weekly basis, or on a yearly basis, right? It's at least, I could say, at least more than 3 maybe, or maybe 4 or 5, and this is going to keep on growing. I mean, in the next couple of years, in the next couple of months. And Avail DA is this ZK or validity proof driven DA layer that is verifiable and secure, and allows you to spin up cheap, reliable, and secure rollups for your use case. And with the number of rollups that's being coming up, there's going to be fragmentation, and that's why we have Avail Nexus that's trying to unify these rollups through proof aggregation and asynchronous composability among these different rollups. And by bringing together ecosystems of different chains together, we want to also be sure to bootstrap enough crypto economic security, not only cryptographic security on our network, because obviously if we are connecting through Nexus cryptographically all these ecosystems together, but the problem is there is also a cryptographic thing that we need to be thinking about, and that means Avail Fusion kind of allows you to provide that additive cryptoeconomic security, which I'll go into soon, right? So essentially, like the permissionless unification layer for Web3, Avail DA, Avail Nexus, and Avail Fusion. So what is Avail DA exactly? It is the a validity proof based DA layer for the next generation trust minimized applications. So you can basically spin up a rollup on Avail using Avail DA, right? And I don't know how many of you know what DA exactly means, but to just give you a quick brief on that, right? On a monolithic chain, for example, right? For example, Ethereum, if you just take Ethereum as it is, it does the execution, it does the consensus and ordering and data availability of that chain itself, right? So you get a bunch of transactions, right? And you execute it, right? And how do you execute this, right? You execute this with this data that is there. So if anyone wants to verify if the execution was done correctly, you need that data. And this is what data availability means. So on a monolithic chain, this is a given, because every full node who is executing these transactions and every validator who is verifying these transactions will have to anyway run a full node, and hence data availability was not much of a conversation before. But as we move to this rollup centric roadmap, as we start moving into this modular ecosystem that we have, where we're decoupling execution, right? Basically, rollups are basically decoupling execution from the main chain, because you have different kind of VMs like ZK VM, ZK EVM. You can have an EVM or a Solana VM or a move-based VM, whatever you want, right? And when you're offloading, you're decoupling execution here, you can also in the same way decouple data availability from the main Ethereum chain, so that you can make it more verifiable and secure. You can use light client-based sampling, as well as easy verifiability, and also it's cheap, right? So Avail DA is this modular base layer, provides raw block space for chains. It has a robust validator set. And basically the main thing that you want to understand is here that just imagine Avail DA or Avail as a place for you to publish transactions without interpreting it. So Avail does not interpret the transactions that you, or the data that you put into Avail. You can put any raw data. It does not matter what it is. Avail does not interpret it in any way. Your application can interpret it however it wants to, based on your application's logic, and that is the magic of it, right? So that means Avail is compatible with all of the VMs out there. Like it is agnostic. It is chain agnostic. It's ecosystem agnostic. It is neutral. It's incredibly neutral. And yeah, so Avail DA Light Clients is another superpower that we have. Basically, it leverages the KZG polynomial commitments in the block headers to do data availability sampling, which basically means light clients like for example, in Ethereum or in the general context, light clients just pull headers, block headers from the full node, but it is not able to verify if the transactions itself or the block itself is valid, right? It trusts the full node there, right? And the difference here in Avail is the light clients don't have to trust the full node because they themselves can verify using this technique called as data availability sampling, which I'm not going to go deeper into at this point, but definitely if you want to, you can reach out to me later and I can go a bit more deeper into that. But essentially it does this thing called as data availability sampling, which allows you to trustlessly, like your light client can trustlessly verify that this block is valid and without even downloading the entire block, hence making it light. So it's based on the substrate architecture, and yeah, we have a P2P light client network. That means each light client communicates with each other, and we are also able to reconstruct the state of the block because of the P2P light client network. I'm not going to go more into this. Then we have Avail Nexus. So Avail Nexus is this unification or coordination hub that we have for different rollups. So like imagine we have thousands of rollups that's coming up. Right? Like just look at this image that you see here on my right, and you see that for all of these chains that are in this ecosystem, if we want to connect or communicate with each of them, you need to have a bridge. Like each line over here is basically a bridge, right? And this is just for like what, 7 chains? Imagine there's like hundreds of chains. You need to have a 1:n connection from your chain to another chain to be able to communicate with them, and that is a problem. So what does Nexus allow you to do? It basically gives you this one unifying coordination layer using proof aggregation to kind of coordinate among these different layers and verify the execution or the state transition function proofs of these different layers of these different chains, which you can use for basically enabling asynchronous composability and stuff like that. Yeah, so mostly for the hackathon perspective, for you, like Avail DA would be what you would be using. Avail Nexus is still in product, like it's still being developed, and we're targeting like maybe 2024 or late 2025 as well. Yeah, so Avail Fusion is essentially a unifying layer, needs unified security, and because we are now, like I said, if we are unifying all of these ecosystems together, we need to have cryptoeconomic security guarantees as well, which is what Fusion allows by allowing you to like stake Bitcoin, Ether, and any other rollup token that you want onto the Avail consensus layer, so that you can contribute to the security of the chain itself, right? Yeah, so that's pretty much what I'm going to go into today in terms of like explaining about Avail. So what I want to also go into is just try to show you around our Explorer. Just give me a second. All right. Yeah. So this is a developer-focused Explorer that we have. So in this, basically, you are able to check out the transactions, the events that's happening in the network. You'll be able to see like when a balance transfer has happened, when a data availability, when someone has sent data to the Avail network, and basically you see the data hash over here. You can see who has sent it, and if you want, you can even go into the block here, and you're able to see what all extrinsics have been executed here. Right, so this is at explorer.avail.so, which you can also try out. One thing that is really cool here is that when you go to the developer section here, you can actually try out the different extrinsics. Extrinsics are basically functions that you have to that you can use to kind of interact with the Avail node, right? You can consider this as like, interactions that you're doing with the Avail node or to basically do some particular functions. For example, if I go here, if I go to data availability extrinsic, I can now create an application key. So what an application key is basically like Avail's block space. Like when you're sending a data, you can create your own app ID for your address, right? And what that does is essentially you can send data to that particular app ID, just saying that, okay, for this particular app ID, I'm sending XYZ data. So what it helps you to do is later on when you want to filter data or like you want to retrieve data back from the block, you don't have to download the entire block. You can just filter based on the app ID of your application. So if your application ID is 3, all you have to do is query based on app ID 3 and retrieve just that data from the entire Avail block. So this is also possible with the light client. So when you're running the light client, you can, if you like in the config file, there's an option where you can put in the app ID number, and if you do that, your light client will only sample or like fetch data of your particular application. So now you can just run a light client. You don't even have to run a full node. You can just run a light client, fetch that data, and then maybe you want to store it somewhere or you want to do something with that data, you can do that. So it's pretty cool. Now, for example, I can also submit data, right? So this is, so you can do this programmatically, like with Avail.js, I'll show you how to do that. So, but this is just from the UI perspective. So if I want to send the data ABCD, I can send that, like submit transaction. Now, right now, this is at app ID 0, as you can see. So app ID 0 is like the default app ID. So in this, all the extrinsics are possible. But for any other app ID greater than 0, you can only do data submissions. Right, so if you want to do a balance transfer, for example, you have to do it on 0, app ID 0, because that is where all of the extrinsics are enabled. But for anything greater than 0, you can only do data submissions. So right now I'm doing a data submission at 0, which you can also do because I haven't created an app ID. But if you want, I can show that also. And I'm just, so yeah, so you'll need a wallet like Subwallet or Talisman or Polkadot.js to use this Explorer, because this is based on Substrate. And you can see something going on over here. And there's like a 20-second block time here. Let me check. Okay, I think it should have been submitted. What is my 5GW? Okay. It should be somewhere here. Yeah, so this is the data I submitted here, and you can kind of check it against here. And yeah, so the data I've submitted is this, right? And you can find it over here, and you can basically decode it if you go over here, right? So you can basically use this Explorer to kind of do your developer operations here. But if you want a more user-friendly one, which is much more friendly, like just so that you can maybe just put in a transaction hash and see what's happening, you can use our Subscan Explorer, which is probably here. So this is at avail-turing.subscan.io. So this is our secondary block Explorer. It's taking some time to load. But yeah, basically this is the more user-friendly version, but it's not very developer-friendly. Like you can't like put in the extrinsics and test stuff out. That is for the other Explorer that I just showed you. But over here, like you can just put in the transaction hash. You can look at the extrinsics here. You can look at all of this data here. Like all of that is cool. But now what I wanted to show is, apart from all of this, there's how do you program this, right? How do you interact with the Avail network directly with like JavaScript, for example? So we have support for JavaScript, Rust, and Go. So for example, the one which I did now, submit data. I submitted some data right now. How does that look like in code? Would be here. So like if you go to our GitHub at Avail project/Avail, you will go to Avail.js, examples, node examples, source, and you see data submission. So what does this even look like? Yeah, so essentially what you're doing here is You're initializing the JS SDK, you are picking some stuff from the config, but essentially what you're doing here is you're initializing the API, and you are getting the account details, so you're getting the keyring, um, and the app ID, right? So like I spoke about the app ID right here, so you can program it to be like whatever app ID you want it to be, but essentially over here, it's asking if in the config, the app ID, if it's 0, just keep it at 0, or else use whatever app ID you configured, right? So basically you need to have an app ID, the nonce, all of that set up, what is the data that you're gonna send, and what you're gonna do here is now, you're gonna use the API, you're gonna call the transaction, and then you're gonna call the data availability extrinsic. So in the UI, how it looked was, let me pull up that UI. I don't really know where it is. Wait. Yeah. So in this UI, when I went to extrinsics, I called data availability here and submit data. So this is data availability submit data, and on code, like in JS, how it would look like is api.tx.data availability.submit data, and then you're inputting the data in, then you're signing and sending it with the account details, the options, which would be like the app ID, the nonce, all of that, and then you're getting a result back, and you do whatever you want to do with the result. There's some example for transaction handling and all of that. But essentially, this is what you're doing, right? And then this is how you can also get back whatever data that you've sent. Basically, you go to the block, you check, you go through the extrinsics that's there, and you find the transaction and retrieve the data. So yeah, so this is how it would work on a JavaScript perspective for you. And there's multiple different examples. Like if you want to do just a balance transfer, for example, there's an example for that, right? So you can just go through this repo and let me know if you have any doubts. And now for the hackathon, right? So what do you need to do? So we have got multiple bounties here. Let me check. Yeah, I think we've got multiple bounties yeah, all right. Yeah, so in terms of bounties, what we have is, 1, best use of Polygon CDK, Arbiter Orbit, or Stacker SDK with Avail DA. So these are basically just frameworks where you can spin up a rollup. So you don't have to basically interact with Avail directly. You just have to spin up a rollup already. So Polygon and Arbiter already have their own tracks for CDK and Orbit. Now, we already have an integration with them, and you just have to spin up our version of it. And you'll be eligible for their prizes and our prizes as well, which is pretty cool. And you can build any use case that you want. Stacker SDK is if you want to build like custom application specific chains, that is maybe like short-term micro rollups. Maybe like if it is like, for example, a game, right? If it is a game, maybe you want the game to maybe live only for the duration of the game. Maybe that rollup should only live for the duration of the game. And then after the game ends, maybe the rollup can be discarded away. If that is the case that you want to do, Stacker could be something that you can look into because it is easy to spin up and easy to discard. It is like an ephemeral rollup, basically. So maybe look into that if you want. I can help you get connected with the team. There are some team Stacker members here who are also they're good partners with Avail, and they also use Avail DA underneath. So all of these things use Avail DA underneath as well. And then also, now if you have any use case that has maybe not spinning up a rollup, but you want to publish some data to Avail, like I just showed you, like submit data to Avail, and you want to retrieve it and do something with that, you can be eligible for the build with Avail track, and yeah, you can do what specific application you want to build with it. Also, if you are more of a smart contract developer, right, you don't really want to spin up a rollup, or you don't want to interact with Avail much, but you want to build some Solidity smart contract, for example, we've already deployed an OPStack testnet rollup for you, where you can just deploy your Solidity smart contract, and so you can just deploy your dApp on that and be eligible for some prizes there. And then another one is like best core tooling project. So like if you have any ideas on how to improve the Avail's toolings, for example, like a DA cost calculator, like what would it cost, like just a front-end dashboard that would be like sending 1 MB of data to Avail would cost this much, 1 MB of data to Ethereum would cost this much, maybe to Eigen or Celestia would cost XYZ amount, right? So something like that would also be pretty cool to see. Even validator operations that you can see here, right? In Substrate, essentially like when a validator stakes their tokens, the rewards are not, you'll need to manually claim it. So maybe you can create a script maybe or a dashboard for people to like claim it on a weekly or a daily basis, something like that. Some tools that can maybe just help the ecosystem as a whole. So these are some tools that you can do. How much time do we have? I think we have time, but so I'll just quickly move on to like how to like spin up an Arbitrum orbit chain, just to give you a quick overview of that. So basically, it's pretty simple actually. We've actually documented all in the docs here. Basically, you will need a Docker, and with the Docker, you just pull the node and the the requirement prerequisites from here. You kind of change the env. So what you'll need to do is, once you've downloaded the requirements here and built, you have to modify the env file. So what that would look like is, so on the env file, you need to basically, yeah. So on the env file, okay, this is not zooming. Yeah, okay. So on the env file, you need to mention the rollup creator address, which is already mentioned on the doc here. So this address you need to paste over here, which I've already done. And then you need to put in your DevNet private key, which is a spare one, which I've put in. So it doesn't really matter what you do with it at this point. But yeah, so you have to put that in. Then all you have to do is go into the script folder and modify the config file. So what that would look like is, if you go to config.ts here, we've got a config file, and you just have to basically, so based on your machine, so if you have an AMD machine, AMD 64 architecture machine, you need to put the Wasm module root as this. And if it is an ARM architecture machine, you have to put this, and just put in this config, essentially. And it would look basically as this. And pretty much you just run deploy, your smart contracts are deployed with hard hat, you'll get an output similar to this, right? This probably will take some time, which is why I'm not running it live with you right now. It will probably take maybe 5 minutes, 10 minutes sometimes to just compile and run, because it's being deployed on ARP Sepolia and depends on the network conditions over there. So I don't want to risk wasting time on it. But yeah, essentially, this is what it's doing. It's deploying these contract rollups over there, and you will get some information. So as you see here in this image here, right, you'll need to keep these contract addresses safe, right? Over here, once the contracts are deployed, you need to keep the contract addresses safe. You need to keep the block number safe, because eventually, in the next step, when you're doing the Orbit setup script here, so you git cloning the setup script, get into that folder, just change the node config. So how that node config will look like is, it would be looking like this. So basically in this line, let me see if I can word wrap it. Okay, yeah. So basically in this part, what you need to change is, you need to change your chain ID based on the config that you had initially put in. So like when you had initially put in, yeah, somewhere over here, you must have put in your chain ID, right? So you need to configure it based on that. You need to change that. You need to also add in some of the other important information that is defined. It should be defined somewhere here. Yeah, let me check. No, not this. Okay, anyway, so I think there was a change in the docs, but anyway, if you actually go through, yes, sorry, my bad. So yeah, in that config file, you need to change these things based on the contract addresses and all of the information that you have based on your deployed smart contracts. And it's like, basically you need to change the chain ID, the name, the initial chain owner. So these are, this would be an address. Again, this would also be the private key and the address, the seed phrase of your Avail wallet. You need to put in your app ID. So you need to create your own app ID for this. You can create it programmatically if you want, which is again an example that is already provided, or you can also, yeah, or you can also go to a website like this that we have created. So all you have to do is sign in with your wallet, and you can just click any wallet, give some name for your, yeah. So you can give a name, so like I can give it a name like testing 1 2 3. So I'm going to create an app ID for my particular um, wallet here. So I'm just going to create a app ID. Oh, okay, my bad. I had two transactions at once, that's why it's happening, but it should work. And then what would happen is you'll get an app ID here, which you would replace in your config in this, right? So the app ID would be coming down somewhere, yeah, somewhere around here, which you'll need to configure. So all of the details that you need to configure is on this documentation itself. So it has already listed the parameters you need to change, and then you just Docker compose up and it runs. So like this is basically the chain running at this point on Docker. You'll have the the URL that you need, the endpoints that you need to interact with the network will also be there, which you can use. So that's pretty much it. I know we're short on time, so that's why I didn't want to like get into the actual implementation and just went through the docs. But we have a booth here. If you want to, if you have any problems in executing this, just let me know, and I'll be here to help. Also, yeah, we have a Polygon CDK docs also. It is not officially on the docs, but you can use this document as well. I've added it on the resources page of our prizes thing. So there's a hackathon dev onboarding cheat sheet where you can like find all of these documentations already listed out, so that it's easy for you to do it. If there's any questions, I can take it if there's time. Yeah, okay, yeah. If there's any questions.
This kind of like configuration let me kind of build my own like fork Avail and support other like rollups or any network. If I want to use Avail to support any other rollups which is not currently supported, is it possible? And if yes, how? Thank you.
Okay, yeah. So you can build. So currently Avail supports OpenStack, Orbit, CDK. I think we support Madara, and I think we're working on an adapter with ZK Sync as well. So if there is any other roll-up stack that you want to integrate with, you will have to build an adapter for that particular stack, right? You could build that for the hackathon maybe, but I don't know how complex it would be to build for just maybe 1 day or 2 days of a hackathon. It takes pretty much some time, so it's more complex. But yeah, I mean, if you want to attempt at it, you can. You just have to build an adapter. You can look at the reference of our already existing adapters and see what's possible. Yeah, thank you.